All right, let's take a look at what we call a particle motion problem. We have a particle moving along a line according to this position equation, s of t equals 2t cubed minus 9t squared plus 12t minus 4. And here they're giving us the domain restriction that time is greater than or equal to 0. So when it says particles moving along a line, it's just think of the x-axis. It's moving back and forth along the x-axis. So first they want to find out where distance is increasing, and that means that the velocity is going to be greater than 0. So to handle this, we need to take s prime of t, which is, by the power rule, 6t squared minus 18t plus 12, and then we need to know where where velocity equals 0, because we need to basically figure out where velocity is positive. To do that, you need to know where velocity changes signs. So if I factor out a 6 here, I'm going to get t squared minus 3t plus 2, and that further factors to 6 times t minus 2 times t minus 1. So that means that there are 2 zeros of the velocity function at time equals 1 and time equals 2. So what we're going to do now is something that I like to call a number line analysis. And we're going to put time on a number line. And I'm starting here at 0 because they restricted our domain to time greater than or equal to 0. And on this number line, I'm going to put in the 2 zeros of the velocity function. I'm going to label this velocity as a function of time. So now I need to know where velocity is positive to understand where distance is increasing. So let's take a look at each interval. Let's go from 0 to 1 first. Let's plug it into the factored form of my velocity function. So try a number like 1/2. If I plug in 1/2 here, I get a negative times a negative times this positive 6. So that will give me a positive value. So velocity will be positive on the interval from 0 to 1. On the interval from 1 to 2, say I chose 1/2. 1/2 minus 2 is negative. 1/2 minus 1 is positive. So I have a negative times a positive, which is a negative. That means velocity is negative on the interval from 1 to 2. Now choose a value to the right of 2 on the number line. Try 3. So I'm going to have a positive times a positive, which is positive. So I have 2 intervals on which velocity is positive, which means that distance is increasing. And those intervals are going to be from 0 to 1, union 2 to infinity. And you would state that position or distance is increasing because velocity is positive on these intervals. Let's take a look real quick at the endpoint 0 here. If I plug 0 into my velocity function, do you see how I get out a positive number? Because I have an endpoint that is artificially put in, there would not be a restriction on the domain of the position function unless we put one in. So that means I have to check endpoints. This is something we've mentioned before, but we need to reemphasize here. You must check endpoints to see if they're possible solutions. When I plug in 0 here, I do get a positive number, which means that at 0, velocity is positive, so the distance is increasing. That means I am required to put this as a hard bracket. Okay, next question says, please tell me where velocity is increasing. Well, velocity is going to increase where acceleration is positive. So what you're going to want to do here is take s double prime, which is my acceleration function, and you are going to differentiate using the power rule. So 6t squared goes to 12t, and negative 18t goes to just negative 18. So we're going to do another number line analysis. This one is a little bit easier because I can see right off the bat that if time equals 1/2, my acceleration, or s double prime, will equal 0. So my number line will look like this. I have to label it as acceleration, and then I'm going to plug in 1.5 as my 0, and here I've still restricted my domain. Now let's plug in number 1. If I plug in 1 into here, I get out 12 minus 18, which is negative. If I plug in a 2, I get 24 minus 18, which is positive. So velocity will be increasing when acceleration is positive, and in this case, that is on the interval from 1.5 to infinity. Now, With acceleration, you can never include endpoints of intervals, so there is no need to check any endpoint like we did up here for velocity. Velocity was very important that we check endpoint of intervals. Acceleration, we don't have to do that. So the next question involves speed. Speed is the absolute value of velocity. And there are tricks to remembering how to find out where speed is increasing. Speed is increasing where both acceleration and velocity, that's A and V, have the same sign. And then you would say that speed is decreasing, even though it's not on this page, I'm putting it in here. Speed is decreasing if acceleration and velocity have the opposite signs. And before we do the math on this, I'm going to show you some graphs really quickly. Let's think about what this means for a function. Let's look at the exponential growth function. On this function, do you see how velocity is positive because the graph is increasing, and acceleration is positive because the graph is concave up? This is an example of where speed would be increasing. Let's look at exponential growth, but in a negative direction. So this is when you start with a negative value and it grows exponentially into negative infinity. For this one, I have velocity negative because the function's decreasing, and acceleration is negative because the function is concave down. This is another example of where speed would be increasing. The thing that these two graphs have in common is that as x goes to infinity, the y value diverges into either infinity or negative infinity. So now let's take a look at what would happen if we have velocity and acceleration of opposite signs. So we're going to take an exponential decay graph. On this graph, I have velocity negative because the function is decreasing, but I have acceleration positive because the function is concave up. So I have opposite signed acceleration and velocity. That means speed is decreasing. Let's do another exponential decay, but this time starting with a negative value and decaying towards 0. In this case, velocity is positive because the function's increasing. Acceleration is negative because the function's concave down. So once again, opposite signs here, and we have speed decreasing. Do you see how in both of these functions, both of these graphs, as the function goes, as x goes to infinity, the y value tends toward a limit or a constant. It does not diverge. It converges on a number. So that's graphically how you can tell, but really what you want to do is just memorize this. Speed increases if acceleration and velocity have the same sign. Speed decreases if acceleration and velocity have opposite signs. So how do we know? Well, let's look at our two number lines. Do you see on 0 to 1 how velocity is positive, but acceleration is negative? Opposite signs, speed decreasing. Let's look at 1 to 1.5. Velocity is negative, acceleration is negative. On that interval, we have the same signs, and therefore speed is increasing. So we're going to have our first interval as 1 to 1.5. Now let's keep going. From 1.5 to 2, velocity is negative, but acceleration is positive. Opposite signs means speed is decreasing. From 2 to infinity, velocity is positive, acceleration is positive. Same sign, velocity is speed is increasing. So 2 to infinity. Those are the intervals for which speed is increasing. Determine the speed at time equals 3.5. What you're going to do is take velocity at, I don't know if I just said 3.5, I meant 3/2. So take velocity at 3/2. So go back to your S prime curve and plug in 3/2. So 6 times 3/2 squared is 9/4 minus 18 times 3/2 plus 12. And if I work all this out, I get, let's see, 9 times 6 is 54 over 4. That's 27/2. 18 times 3 is 54 over 2. That's 27 plus 12. Now, that's going to be a 13.5 minus 27 is negative 13.5 plus 12. This is negative 1.5. But they asked us for speed, and we just got velocity. So to take speed, you take the absolute value and you get 1.5. We don't have any units on this problem, so I can't be using units. Okay, last thing that they've asked here is for what the total distance traveled is between 0 and 4 seconds. And I'm going to give myself a little bit more room to work by erasing this work down here. And what I want you to do for this one is to basically create a little sketch of what's going on with this particle. It's starting here at time equals 0, and it's moving to the right for the first second. We're using this velocity information. So we're moving to the right for 1 second. At time equals 1, the particle moves back to the left. So this is right-hand movement, and then we go to left-hand movement. And at time equals 2, the particle turns around and it goes back to the right, and it's going to go up to the right forever, except they're only asking us between time equals 0 and time equals 4. So this tells us what's happening at time equals 0, 1, 2, 4. Now we need to know how far the particle traveled on each of these intervals. So from time equals 0 to time equals 1, I basically just need to take the position at 1 minus the position at 0. The position at 1 here is going to be 2 minus 9, which is negative 7, plus 12 is positive 5, minus 4 is 1. And then S of 0, if I plug in 0 here, I get out negative 4. So I have subtracting out a negative 4. That means that my particle moved 5 to the right in that first second. So I'm going to say that here. It moved a total of 5. Then to get from 1 to 2, what I'm going to do is find S of 2, which I get by plugging 2 in here. I get 16 minus 36 is negative 20, plus 24 is 4, minus 4 is 0. So S of 2 is 0. If I subtract S of 2 minus S of 1, I get 0 minus 1. So S of 2 minus S of 1 is 0 minus 1. That means that this particle moved negative 1. The negative just means it moved to the left. So what it moved in the distance was just a positive 1, because when you move to the left, it doesn't mean you're going a negative distance. You're just going in a direction of a negative. So the distance is still a positive. It's like the absolute value, kind of like how speed is the absolute value of velocity. Distance traveled will always be positive. So now I need to know where this particle is at 4. And if I plug in 4, I'm going to get 28. So that means that when I look at where the final position was at 4, I got 28. And from 2 to 4, I moved right by 28. So the total distance that this particle traveled was 5 plus 1 plus 28, which is 34 units. Okay, if we had been asked for displacement, we would have taken the ending position of 28 minus the starting position of negative 4, and the net change in position would have been just 32. But what happened was that this particle backtracked by 1 here. So it went 1 to the left and had to recapture that 1 to the right. So total distance traveled was 2 more than net displacement would have been.